We are as of right now, I think. I don't know. I'm confused at this point. Am I recording or not? There we go. Okay. So yesterday we were talking about using vertex form of a parabola, right? And so I think at the end of class, what I had done is I gave you a few to do on your own. And then we have some that we're going to look at together because they're a little bit different. And then we're going to look at how to graph some. And then I'm going to have you work on your own again. Okay? So if you look at this equation right here, number 8. Y'all see this one?
That's one of the things. It's just what we've done before.
Right. So it's not in, it's in what's called factored form. That's what this is called. It's called factored form. And it is a form, and it's something we're going to talk about in more depth like tomorrow. But for today, we just want to put it in vertex form. That's what we want to do. So what we're going to have to do is multiply this out to put it in standard form first, so that we can use the information from standard form to put it in vertex form. Okay? So we're going to do our distributive property and do x times x, x times 4x, 5 times x, and 5 times 4. And then simplify anything you've got there to simplify. So do we have anything we can simplify? And that gives us x squared plus 9x plus 20. Now it's in standard form, and we know that our a is at understood 1, and our b is 9, and our c is 20. And we can use this information to now go find our vertex and put it in vertex form, right? So to find our vertex, remember we're going to find our h first.
So 9x.
9 over negative 2 times 1, which is going to give us a decimal. What's that going to give us there? Negative 4.5. And then we'll use that to plug into our original equation. So we can put it either in our one we multiplied out, or we can put it in the actual original equation. Either way, it doesn't make any difference. The actual original equation, the math's going to be a little easier. So if we put it in the original and we do negative 4.5 plus 5 times negative 4.5 plus 4, let me move this over. So you get negative 0.5 on this one and positive 0.5 on that one. And we don't even need a calculator for this. What's 5 times 5? 25. And how many numbers do you have behind the decimal? You have 1 here and 1 here. That makes 2. That means you're going to put 2 numbers behind the decimal here. So it would be 0.25, but what's a positive times a negative? A negative, so it's negative 0.25. So our vertex for this is negative 4.5, negative 2.5, right? So to put it in vertex form, we'll just plug those in. Well, we need our a. What was our a? 1. So when we go back to our multiplied out form, that's 1. So we don't write anything because it's a 1. And then we would do x minus negative 4.5, which is plus 4.5, squared, and then minus 2.5 because it's a negative. And that's our factored out form. Or not factored out form, vertex form.
How would it be 2.5?
Oh, not 2.5. Good catch on that. Negative 0.25. I'm not wearing my glasses, so Sometimes, y'all, I'm writing and I can't really see it. I just have a general idea of where it's at on the page. Okay, so number 9 looks crazy complicated, and it actually is one of the easier ones on the page. Yep. Because, remember, our goal here is to put in vertex form. And everybody's always like, let's get rid of the parentheses, which we could. But I want you to remember, vertex form looks like this, right? Now, look at the equation we have and compare it to vertex form and tell me something you notice that's similar. See how we've already got that, like, formatted like that, right? So we don't need to get rid of those parentheses. We just need to get the y all by itself. If we get the y all by itself, we're good. We're golden, right? So that means we're going to get rid of this 4 and we're going to get rid of this 1/2. Which one are we going to get rid of first? The half, because it's outside the parentheses. So you get rid of it first and then you deal with the 4 because it's inside the parentheses. So how do we get rid of 1/2? So traditionally we will say divide by 1/2 because it's being multiplied, right? But when you're dealing with a fraction, there's a better way. Instead of dividing by 1/2, we can multiply by the reciprocal. And what's the reciprocal of 1/2? 2, because it's 2 over 1, which is just 2. So we can just multiply both sides by 2, right? So over here they cancel, and we have y plus 4. And over here, we're going to put that 2 outside those parentheses and write it like that. What is that 2 in our vertex form? Our A. That's our A right there. Now we have one more thing we got to do. So how do we get rid of that? We subtract it. So we're going to subtract. Now when we subtract over here, we're just going to show we're subtracting. I told you, right? So number 10 is a little different. It's not really remotely close to vertex form. But what is it close to? Pretty close to standard form. What's wrong with it that makes it not be in standard form? So we could either say the y is off in the middle of things, or we could say the x's are on the wrong side. And either way, our solution is pretty much the same thing. We're either going to have to move this y over and then deal with some stuff with the y, or we got to move these other things over and leave the y where it's at. Either way, you're going to get the same answer, okay? I personally would probably prefer to leave the y where he's located and move the other stuff, because we can do it all in one step, because all we're doing is subtracting those things, right? So we can subtract the 6x squared, subtract the 12x, subtract the 13. But if we do it over there, we got to do it over here too, right? Which essentially all it did was change all the signs. That's all it did, right? Now we have A, we have B, we have C, and we can go on to find our vertex form. So we're going to find our H value. What y'all tell me what to do? Negative. Yes. Now I want to point something out because people mess this up all the time. And I think maybe it was 7th period who was having this issue. If you do this and you plug this in your calculator, it's going to divide the 12 by 2 first, then multiply that answer by 6. If you do this, it's going to multiply, then divide. Is that going to be a different answer? Yes. There's a reason we have order of operations, right? There's a reason for it. Okay, so this gives us 1. It should be -1. I forgot my negative on my 6 there. Okay, so that gives me -1, right? So now we throw that into our equation right here. So we're going to do -6. -6 times -1 squared minus 12 times -1 minus 13. And I'm just going to punch it in the calculator just to make our lives a little easier. And I get -7. So our vertex is -1, -7, right? And so when we get ready to write our vertex form, we're going to have y equals, what was our a?
6.
-6, parentheses, x what? So +1 squared, and then what? And that's it right there. That's the whole thing. That's our answer. So earlier today, I tried putting my reading glasses down on the end of my nose so I could see y'all over, or see my class I had at that time over them and still be able to look down. Y'all, I can't do that. I just can't. Like, it actually physically hurt my eyeballs to switch between the two. Like, I can't do it. I can't. Okay, number 11. Let's look at number 11 real quick. Tell me what you think you should do on number 11. What would you do? So that's one option. That's totally acceptable and works and is okay. There is another option that I do want to talk about though, okay? So what if we left the y? Yes. So what if we left the y, but we added the 9x squared, right? So over here, we're going to add the 9x squared. And because it's the x squared part, we're going to put it first. Now, we still can't leave that y as a negative. So we have two options. We can divide by -1 or we can multiply by -1. And they both yield the same answer, right? All you're doing, if you divide or multiply either one by a 1, nothing changes. But by a negative, you change every single sign, right? So no matter which way we go about it, what's happening is that becomes a negative. That becomes a negative. That becomes a negative. And that becomes a negative. If any of them had been negative to start with, they would have become positive. Like this. This became positive, right? So now we have our A, our B, and our C, and we would just go forward and use our vertex form using that A, B, and C. Okay? Circle number 12, because you're doing that one. Circle number 13, because you're doing that one. And number 14, you're also going to do. And this number 14 is literally the easiest one on the entire page. Look it over. What are you going to do? Just subtract the 6. That's all you have to do is subtract the 6. That's it. Okay, flip this paper over. Go with me. We're going to take a little journey to some graphing. Okay, so we're learning about these, but why? What's the purpose? What's the reason behind us having vertex form and using it and understanding it and all that? Well, because it's useful. If you look at vertex form, it tells you the vertex, which is one point on your graph. But that's not all it tells you. It also tells you the axis of symmetry. And it tells you if the graph opens up or down, right? So what is our vertex in this equation right here on 15? It is 2 and negative 4. Now let's talk about why. Remember, the equation is x minus h, right? That means that whatever h is, it's going to be the opposite of what you're thinking right there. It's minus 2. Minus is part of the equation. The 2 is just the number, right? So we know this point right here, 2, negative 4. So over 2 down to negative 4, that's a point on our line. Not only is it a point, it is the vertex. It's either the maximum or the minimum one, right? Now, this will tell us which one it is. Because what does that tell us? That's the A. What does the A tell us about our graph? If it opens up or down. What does a negative A tell us? It opens down. A negative makes a frown. A positive makes a smile, but a negative makes a frown, right? So that negative opens down. So we know that's our maximum. That's as high as it's going right there. We're not going above that. We also know that right down through this vertex is our axis of symmetry, which means whatever point we have over here matches up with the point over here, right? So if we find a point on this side, we can just duplicate it on this side, the same distance away from the axis of symmetry. Now, we're going to find a point. But let's use a little bit of common sense with it, right? We're going to be plugging an x value in here, but we got to be able to graph it. And we know we're going down, right? Now, it could be down like this wide, or it could be down like real narrow. So we want to start pretty much in this middle. Did you bring us food, Eurydia? I marked you absent. I didn't know you were doing something. Okay. Let me fix this. Was Emily down there?
Yeah. She's almost done. Well, they take a little bit.
I forgot to mark Trenton and Landon here. I'm not sure Landon's here.
He's present.
He must be tired. Okay, so what x value do y'all want to use?
Wait, what?
So what number do you want to use for x? 1? Alright, so let's stick a 1 in there. Let's see how it turns out. So what is 1 minus 2? Negative 1. What's negative 1 squared? Positive 1. What's negative 3 times 1? So what does that give us? So if 1 is our thing, then negative 7 is our point, right? Now, we also know that we got a buddy over here that matches up to that, so we can go ahead and plot that guy. And then that's that, because we know there's no way we're going to fit another point on there, right? We're limited on our graph. If we'd had more graph, we probably would have wanted one more point, just so that we have more of an idea of where it's going. But since we don't have enough graph, we just stop there. Okay, so look at number 17. What is our vertex?
Negative.
Our our vertex is negative 4, 3, right? So negative 4, 3 negative 4, 3, right there, which means we also know that's our axis of symmetry. And what does this A tell us? It actually tells us two things. We only talked about one of them a while ago, but it tells us two. We know it's opening up because it's positive, and positive makes us small, right? Being positive is a happy thing.
Why is it the negative
Remember that the equation is x minus h.
one? Oh, okay, so that's the minus.
So to get a plus, you have to have a negative. Okay? Now, what about that 1/4? What else is it going to tell us besides that it's opening up? Anybody remember this? Yeah. So, because it's less, nope,
No, less is wide.
less is wide, but it's closer to 0. Think of it like this, okay? I'm going to use one of these rulers, and I hope to goodness I don't break it. This is a horizontal line, right? Horizontal line. Horizontal line has a slope of 0. 0. If I bend this real close like this, that's far away from 0, right? Far away from 0. But the closer I get to 0, the closer I get to it being a horizontal line, what happens to its shape? It gets wider. So the closer to 0 you are, the wider that it's going to be. And it works the same way if we go this way, right? The closer to 0 we get, the wider it's going to be. So the smaller the absolute value of that number is, the closer to horizontal that shape is. Does that make sense? Okay. So that it looks discomfortable.
Why did I think those are real lips?
Sometimes I feel like I've been invaded by aliens or something, and they've just taken over. Now, I'm joking, just so everybody knows. I do not believe I've been invaded by aliens, okay? Don't be telling anybody that Miss Martin thinks she's invaded by aliens, because I'll get checked into somewhere. And I don't think that. I don't think that that's a thing.
And then the nurse will try to convince them that you don't think that.
Yeah. Yeah, they'd be like, sure, honey, sure.
They all say it.
Yeah, we know. Okay. So it's going to be wider. And the reason that's important for us to know is because are we going to want to pick an x value real close to the axis of symmetry? No, we're going to want to get away from the axis of symmetry a little bit, right? And it also might be a good idea to sort of think about what you get in here is going to be multiplied by 1/4, essentially divided by 4, right? Because multiplying by 1/4 is the same thing as dividing by 4. So you want something inside here, or after you square it, you want something that's divisible by 4. So you get a whole number. So 4 is divisible by 4. But if we put 4 in there,
4 plus 4 is 8, and you square it out, and you still do this.
it would. But are we going to be able to graph it? No. So that's not going to work.
What if we did 2? Those 6 is divisible by 4.
Well, is 6 squared divisible by 4, though?
Yes.
Yes.
So 6 squared is divisible by 4, right? But we're going to be able to graph it.
How long?
So
8 plus. No.
What if we just did what?
About 0.
what about 0?
How would we do this?
If we put 0 in there, what's 0 plus 4?
4.
And then we square it,
16.
divide that by 4,
4.
plus 3.
7.
7.
So 0, 7.
Oh, and then match by those.
And then we match it on the other side. You alright back there? Okay, are we going to be able to pick out another number here? We could do some of these in between here, but y'all know what's going to happen. We're going to wind up with fractions.
I don't want to do that.
So we can just,
I did it with -2 and I got 4.
you got the number 4. Good job.
-2 gets you 4.
-2 gets you 4. So my,
You're off.
I'm off a hair. On one side, but not the other. Look at that.
Gotta fix it. That was weird.
Look, it's the best I can do, okay?
Do it again.
Y'all should see some of the ones I did this morning. They're terrible. They'd be like great on one side, the other side would be like,
What do we have to finish by the end of the day?
Don't tell them.
I'm not telling you. Okay.
We got 15 minutes. I think I can finish that.
Well, you'll find out in just a minute. What about this one? What's our vertex?
Vertex.
Vertex.
12.
Hold up. It's, wait, 5 negative.
Almost, Jordan.
Oh, wait, -5.
Remember, this has got to be the opposite, right?
Getting that.
-5, -3. Are we opening up or down? Down, and that's our axis of symmetry, so we know we're going this way, right? And then let's pick a point and throw in there. 2. So 2 minus 5 is -3 squared times 2. Yeah, that's too big. So
So we gotta use a positive number?
-4.
we could try -4. So try -4 in there. -4 minus 5.
Never mind.
But then we can square it.
Oh, that's not minus. That's plus 5. -4 plus 5.
-1.
You were right with 1. 1 squared. 1 times -2. -2 minus 3. So -4, -5. And then we match it up over here. And we might be able to get one more out of that. But you know what? I don't care enough. So,
Wait, can you just go through how you got to the 5?
yeah. So, we put -4 in for x,
Oh, okay.
right? And so -4 plus 5 is 1. And we're squaring 1, but when you square 1, you just get 1. So you've got -2 times 1. And then I always do that add the opposite thing. I just do it in my brain most of the time. And so that's where I got -5 from.
Okay, well, that's
I probably kind of did that too fast. Okay. Hudson. 16, 17, and 18.
add along with 5.
I'm sorry, 16, 18, and 20. And the ones from the front that I told you to circle yesterday.
Okay, so we got
Wait, the one you told us to circle the other ago?
Yesterday. So, this is what you should have. All the ones I told you to circle. You should have 4, 5, 6, and 7. Okay. You should have 12, 13, and 14. And then you should have 16, 18, and 20. So it's 10 problems total. I think. Yeah, it's 10 problems total. Yes, sir.
the whole worksheet.
What?
That's the point. It's for the whole worksheet.
But we did, actually, there are 20, so we did 10 together. We did half of them together.
You do the rest of them.
No? Y'all gonna do them?
Wait, is number 13 on the yesterday's one? Sounds like a stupid question, but
Mm-hmm. Mm-hmm. You're welcome. I need to finish. I done.
Okay.